So just do me a favor, and Zoom decided to update this morning everywhere on my iPad, on my computer. It was like, oh, we're updating now. Thanks so much. Just what I wanted 2 minutes before class, just update everywhere. Ready, we got it. There we go. Oops.
I got my watch fixed.
You did? What was wrong with your watch?
The casing broke.
Mm-hmm.
So mom just broken a couple times before that. So mom literally bought just like 10 different casings. So when this one breaks, put on a new one.
Very smart. Very smart. Okay, I'm gonna turn that around. Nope.
I might have stood on the grinder, not my grinder.
You spilled soda on it?
I might have.
That'll do it.
Like syrup or something.
Why won't it do the thing where it turns the screen around? This thing has been so wonky lately. Like it wants to stare. Where's the screen? Okay. Let's start video.
Time to clean up.
Switch camera. Just doesn't want to do it. Switch camera.
I wonder if I can brush in here.
I have no idea which way it's facing. Fun. Okay, I'll figure that out in a minute. Put my shoes on in case I decide to go outside.
My friend Anna is having her birthday party 4 months late because she has a pool in her backyard.
Oh, that's smart. Okay.
She wanted to be with everyone because back on her birthday party, and ever since then, everyone's been everywhere.
Yes.
And so we're on Sunday, we're heading over to her house. Me, Ellie, Kate, Jack, Talia, Olivia.
Everybody's going.
Everybody's going. And a lot of the people
There it
from my
is.
old Girl Scout troop are going.
Mm-hmm.
So I'm really excited because I get to see them again.
Oh, that's fun. Is it American Heritage Girls though, right?
Yeah.
Yeah, not Girl Scouts. Yeah, that's what I thought.
When I say American Heritage Girls,
People go,
confused,
what?
like, what's that? Like just my Girl Scout troop.
It's like Girl Scouts.
Except it's not like Girl Scouts.
Except it's not. Yeah, in all the ways it's not. That's like Drew trying to explain Civil Air Patrol to people. Somebody at church asked yesterday, he was like, so it's Air Force. Like you can say it's Air Force Reserve or Air Force Cadets, and people will maybe understand what you're saying. That's a tricky one to explain because it is literally the Air Force. Like you are a member at that point, but you're not enlisted or whatever, but you're a member. And so it's tricky to explain. All right, what do I have to hand?
I went camping over the weekend with my
Again? Girl, you camp a lot.
With my AHG troop this time. And right across the street was the Girl Scouts.
Yeah.
And like we all had like half lights out at 10:30. The American Heritage Girls were talking till midnight. The Girl Scout girls were talking till midnight.
Oh my goodness. Yappy. We're gonna get candy.
Yeah, pretty much.
There's that. Don't know where Sky is.
There's that. So you guys are
And who knows where Anthony is? I don't know. Right. I had to send.
Me too.
I had to send.
I think it's because I wrote a little bit my.
No. I think there was something. I think there was one you guys didn't finish. There was like one question you didn't complete or something.
Oh, it was because I drew the shapes really well. I just scribbled them in. And to be fair, that was.
I think it was on the wherever it is. There's a mark. I think it was on the second page. It was like one. I think it was an intro part. So it was a section.
Big bottles. I'm excited. I said big bottles. I'm very excited. There it is. However I want it. So.
So I did something different last night too. Jason and I went to the Punchline Atlanta, which is a comedy club. Oh, and stick it behind my back in a minute. But we have a friend that used to go to church with us. He hasn't been in a long time. But he does mortgages and stuff. So we know he's done our mortgages like 3 or 4 times, refis, whatever. I think Lily's in the wing chair, Drew. And this is your lab 30. And so anyway, his girlfriend got him for his birthday a stand-up comedy class as a gift, which I had never even heard of, but turns out it was actually quite good. So there were probably, I don't know, 12 people in the class, maybe a little less than that, maybe 9. But they got up one at a time and did their very own stand-up routines after that they had like crafted. They'd written them and they'd taken criticism and they changed it, and it was on and on and on. And they were all really different. And what was interesting is there were parameters, like you couldn't use curse words, you couldn't talk about politics, you had to limit like inappropriate sexual jokes, those kinds of things. So a lot of the stuff that you see stand-up comedians do, they couldn't use any of that material. So it was limiting, but they were good and they were all different. There was like 1 or 2 people that kind of bombed where you were like, ha, that was funny, but the rest of it was not. And the last person who got up, the closer, was a lady who was a former student of his from years ago. And she is a professional comedian who used to tour like all the nightclubs and comedy clubs and things. And then from her stand-up routine, I take it that she ended up having a drinking problem, went into recovery, and now she's a Christian comic and goes to churches and does stand-up comedy, which sounds like it would be terrible, but it was actually hilarious.
That sounds really good.
Yeah, she was so funny. I thought, oh gosh, this could be bad. I mean, but no, it was great. It was great. All right, so I don't know if Sky is coming or not. And yes, ma'am.
Oh, right. I don't have lab. I don't have lab 33.
Oh, you don't have a copy of it? Okay. They're online. You can always grab one out of your Dropbox folder. It should be 32. There is no lab 33. So 32 is what you're looking for. It says negative feedback loop. That's the one you're looking for.
Yeah.
All right. So we are on 32. There is no lab 33. This is our last lab today. I'm putting this in your email that goes out this afternoon. Your final exam packet. I'm going to try to get it out to you tonight if I can on the airplane. I'm leaving for Virginia this evening. So while y'all are eating dinner, I'm gonna be driving to the airport. Is that Sky? Who is that? It's Lily. Okay, see that box right there? There you go. So Saturday was my dad's 80th birthday, which was a big deal because if you were around last year, you probably remember he had like a series of strokes and it was really terrible. And we didn't think he was gonna live. So the fact that he made it out and has made it to 80 is a super big deal. So we are going to go have a big party for him on Wednesday. Yes, ma'am.
Were we supposed to turn on our final projects today?
Nope. I'm gonna go over that next. So this is my next slide. So good intro there, Darcy. Heads up before we start our lesson. There is a lot due over the next few weeks. If you want to take a picture of that screen, go ahead, but this is gonna be in your weekly email. I'm not sure how many of you are reading that, but you all should be. So next week on 5/10, that's Drew's birthday. Happy birthday, Drew. You will be handing in your completed My Model Body project, which means the paper project, the big roll of paper, and the booklet. You'll also be handing in Lab 32, which we're doing today, and Unit Test 8, which you will do over this coming week. Unit Test 8 will open at noon. It's already in there, ready to go. I will tell you, and we'll go over it when we get to the test topic slide, there's a lot of anatomy in Unit Test 8. Study your anatomy. I'm gonna put out like an additional anatomy packet. I'm gonna try to do that before I haven't even packed, like it's crazy. This week's been nuts. On 5/15, which is a Sunday, just 2 days before our last class, you need to upload your written research paper to Teacher Ease by 11:59 p.m. So I need it uploaded in PDF format, obviously, to your portal. Yes.
We were supposed to write a written research paper.
Look at the in your syllabus, there's a complete description. Okay. And I'll show you. It's right. If you go into your open up binder. If you go into your preface part of your binder, which is all this stuff at the beginning, right? It's all the stuff that looks like this. This is like the first page, second page, right? When you get past all this stuff, there is this whole page. It's on page 9, and it says exactly what you're required to do. It gives very good detail, and it gives you parameters for your research paper, and they're very specific parameters. Like it says 2 to 3 pages typed. That does not include your citation page. Set bottom, top, and side margins at 1 inch. Use double spaced text throughout your paper. Use a standard font like Times New Roman Arial. Calibri is also fine. Legible size, which is 10 to 12 point. That's your choice. If you have a lot to say, go 10 point. If you have less to say, go 12, right? You can insert graphics or photos, but that does not count towards your number of pages. And then it says you should include a citation page at the end of your document listing all your sources in proper APA format. And up here, it talks to you about citing sources, right? It even gives you this option to go to this website right here. This is Citation Machine. So if you're using a website example, like a Encyclopedia Britannica or something, you can go here and you can say, I have a website, I have a book, I have a journal, and you can click on that and it will tell you exactly how to, hey, Sky, here, wait a minute before you sit. This you. It will tell you exactly how to do your citations. Like it's super, super easy. All right, so back to our lesson. And oh goodness. Okay. So be sure that you know to go over this stuff and get it right. And then on Monday, 5/16, the next day, any overdue assignments, if they're not in by 8 a.m., they're zeros. This is a no exception one because the last day of class is the next day. So there's no extension, there's no exception. Everything has to be in by 8 a.m. Then your final class, you're going to complete your exam. We're going to do our presentations. We'll have pizza. Bring $10 for pizza and cupcakes, please. We'll have pizza and then maybe go to the pool if weather permitting. And I have to keep an eye on the lifeguards. There's rules about like, bless you. If you have, there's tissues under there if you didn't. If you have more than a certain number of people, you're supposed to hire a lifeguard. And like, it's the middle of the day, so there doesn't tend to be a lifeguard there anyway. They don't usually come until the afternoon. So we'll see. We also got Jackie's exams and all that too. So, all right, endocrine system, let's get rolling. So, let me move that thing to the bottom. It's taking up space at the top.
What day do we turn the paper in?
The paper's due on the 15th, Sunday, the 15th.
Okay, so same day as the final project?
Final the My Model Body is due the 10th.
Sorry, the exam.
The exam is on the 17th in class.
Oh.
Okay,
2 days before.
so here we go. Function. What's the function of the endocrine system? So the function of the endocrine system is to produce chemical messengers. We call them something, and they come from your glands and they regulate certain body activities. What do we call the chemical messengers in your body? Where?
Neurons?
Nope, not quite. Colson. Hormones. All right, hormones. Neurons are what transmit messages, but your hormones are what are they're the chemicals acting on those messages. There we go. Okay. And though you've got different, obviously your endocrine system is kind of spread throughout your body, all kinds of different organs. You got pituitary and pineal and hypothalamus, which are all up in your brain, your thymus, your pancreas, your thyroid. You have adrenal glands that sit on top of your kidneys. And then of course you have reproductive hormones in reproductive organs. Now, these adrenal glands on top of your kidneys, it's weird, but they're there on top of your kidneys. But when you think about it, think about how much blood flow goes through a kidney. Remember when we looked at kidneys, we did excretory system. And also when I had the one cut open from my pig, you could see they're highly, highly vascularized. And because of that, it helps this adrenaline get through your body quickly. Why would you want the adrenaline to go quickly through your body, like super quickly? Why would you need that? What's adrenaline do? Sure.
It's like an alarm system.
Yeah, it's your fight or flight. So your fight or flight is what's controlled by your adrenaline. So if you have, anybody have an EpiPen?
It's like steroids.
It is a steroid. Yeah, I have an EpiPen. Yep. Okay. So an EpiPen is it's full of epinephrine, and epinephrine is basically manufactured adrenaline. That's what it is. So if you've ever been in a situation where you're scared or your heart pumps really fast, that's adrenaline doing that. It tells you, hey, there's a problem here. Why is Lori Watkins calling me? She's my real estate agent. And my friend from church. Don't know why she's calling me. So yes, hormones is what we were looking for. So here's a hormone right here. I believe this one is testosterone, actually. No. Yes. Okay, so hormones are chemical substances that act like messenger molecules in the body. After being made in one part of the body, they travel to other parts of the body where they help control how cells and organs do their work. So they act on specific cells, which we call some kind of cells, or the message is ignored. So what kind of cells do hormones act on? Do we know? Anybody? They work on what we call target cells. So if you have, say, adrenaline rushing through your body, it's going to target a lot of nervous system cells, right? It's also going to target anything that will help you raise your heart rate, respiration, get your muscles ready to move, but it's not going to target the parts in your brain that help you go to sleep. Like, right, when melatonin comes out, it's going to help you go to sleep. So that's what, so they're only act on specific cells. So looky there, there's one here. So let's talk about glands. There's one gland that's kind of like the master gland, okay? So we'll talk about that one in a minute. So glands are organs in the human or animal body. Yes, ma'am.
I know what that giant gland in the middle of the brain is.
What is it?
HYP. I can't pronounce
It's the hypothalamus. You are correct. All right. So these are organs or glands in the human or animal body, and they secrete particular chemical substances for use in the body or for discharge into the surroundings. Think for a minute about a gland in your body that excretes some kind of a substance that's for discharge into the environment and surroundings, not going into your body, but going out. Can you think of something that your body produces that goes out? How about sweat or pheromones? You know what pheromones are? Pheromones are chemicals that you give off that you can't smell and you don't sense them, but everybody gives them off. And they can be used in attracting mates, all kinds of things. All right, so you've got different types of glands too. You got over 40 in your body. Some are endocrine, some are exocrine. Anybody know the difference? Very good. So endo excretes or secretes, sorry, whatever their substance is into your body. So then exocrine would be what? Yeah, outside your body, right? All right, stop. So endocrine, ooh, that's British money again. Why do I have British money in here? Y'all been sticking money in my stuff. Yeah, I'm gonna blame you too. So yeah, so your endocrine glands secrete into your body, and your exocrine glands secrete outward. So example of a gland would be your pancreas, and you're going to kind of model the way your pancreas functions today in lab. What we're going to model today is a negative feedback loop. Do you guys remember a couple weeks back, we talked about how your body monitors homeostasis as far as temperature is concerned? And it was like, we used an example of like a thermostat, and it was a negative feedback loop, which means if it gets too cold, your body produces heat. And then if you get too hot, your body cools down and it goes round and round. Whereas a positive feedback loop is like, we had the picture of the cows. Remember, we had one cow that kind of panicked, then all the cows panicked, and then it was a whole bunch of cows panicking. Do you remember little cartoon cows?
Oh, yeah.
Yeah, so that's a positive feedback loop.
And kind of like wolves howl, like another one howls.
Yeah, that's positive. Yep. So hormones are going to work on your target cells. And in this case, insulin, being the hormone, is going to work on your liver and your muscles. So insulin is, they're mad at me because I need to fill up everything. I may have a chance to go do that while y'all are doing lab because they're really mad at me. Everything's out. I was too busy this morning to fill the birds. I was too busy to fill all the birds. They're ticked. See, look at her. She's like, excuse me, where's my breakfast, lady? Yep. Some of them will come and line up, stare in the window. They know how this works because they watch me fill it. So anyway, insulin is the hormone. Anybody know what insulin does?
Insulin helps like regulate your blood.
Yep. What in your blood?
The sugar level.
Blood sugar. Okay. So insulin regulates blood sugar levels. Insulin can be, I mean, everybody has it within their body. People that have issues with insulin tend to be diabetic. There are different types of diabetes and there's different reasons why it functions. Yeah. But you can have insulin pumps. You can have insulin injections. You can take sugar pills and those when people's sugar gets low. But we've manufactured insulin in such a way that it's pretty identical to the one within your body. Yeah.
In Mall Cop 1 and Mall Cop 2, that guy has to get that really old, dirty lollipop.
Oh, yeah, that's gross.
And then in Mall Cop 2, he has to stand under that ice cream cone that's dripping over.
That's disgusting. Yep. So then you have your exocrine glands. So as we stated, they are ducts generally, which are like little tube-like structures, and they secrete directly out of the body or into the digestive system, because although that's inside your body, you have to remember that it's kind of like your alimentary canal, right? Remember, your alimentary canal is mouth to anus. It's that whole digestive system, and it's almost like you're rolled inside out when you're made. So if you took like anybody ever had like a thick, what are they called? There used to be these little worm things. They were filled with fluid and you could squeeze them. It was a tube inside of a tube. You could squeeze them and they would move. You ever seen those? I don't know, but anyway. So even though that part of your body is inside, it's really kind of, it's fun. It's really sort of like external. What you need? Do you need me?
Lori is locked out of her house and she needs Drew to climb in something.
I saw she was falling, but I ignored her. Drew, you can go and watch this video later. I guess you're nice and, is she outside?
She's outside her house.
No, can she come grab him? It would be faster. She's like, who's the smallest person I know? Drew. She's our real estate agent and her friend, but she lives at the other end of the neighborhood. So she needs a little person to hoist up through the window, I guess. And she's not going and her girls aren't going, but they're all big grown up people. So, all right. So anyway, your digestive system, like I stated, it acts like an external part of your body because it comes in contact with external parts of your body. So these are things like tear ducts, bile ducts, and like we said, sweat glands. The tear ducts is a great example, right? You excrete tears onto your face. Yeah, they do. Crocodile tears. So then your endocrine glands, for example, are going to be things that release hormones directly into your blood in particular. So pituitary, adrenal, thyroid. Where's your thyroid? Anybody know? That's right. Sky's got it right there. So when you go to the doctor and they do this thing where they, remember we said they check your glands? They also tend to go here and say, swallow. You ever have them do that? Swallow?
Oh, that feels weird. It goes up and down.
Yeah, well, that's, yeah, you can feel your trachea and your larynx move, but your thyroid kind of wraps right there, and it's very important. Your thyroid basically controls your metabolism, which is how fast or slow your internal engine runs. So you ever heard of hypothyroidism or Hashimoto's disease? That's when your thyroid does not produce enough of its hormones, and there's several different kinds. And it can cause your metabolism to slow down. So it can make you very sleepy. It can make you gain weight, it can make your hair fall out. And you just sort of, you're sluggish. And then hyperthyroidism is way less common where it makes too much. A lot of things can cause hypothyroidism. Sometimes it just happens. In my case, Cole killed my thyroid. Like just being pregnant with Cole. When you're pregnant, when a woman's pregnant, your thyroid on purpose slows your metabolism down because it doesn't want you to burn those calories as fast. It wants you to keep them so they can get into your blood and make their way to the baby, right? If you burn everything as fast as usual, you're not going to be able to develop that fetus as well. So, all right, how are you getting there?
She's gonna drag me.
Okay, go wait for her. She'll be here in like 2 minutes. She only lives the other end. All right, you can watch this part later, or I'll go over it with you whenever I have time. So anyway, usually if you draw blood from a pregnant woman, you're going to see lower thyroid. After the baby's born, you'll still see lower thyroid, and you'll see lower thyroid for about a year. And that's for the breastfeeding stint of time, or at least part of that breastfeeding stint of time, because you want to keep more, you want to slow down the use of all those calories so they can make it into breast milk and get it to the baby. If you go beyond a year, they go, now you got a problem because it never picked back up. Mine never picked back up. Cole killed it. So one of the other problems that hypothyroidism can cause is infertility. It can make it difficult in women. It can make ovulation difficult and things like that. So pregnancy doesn't occur. So had my doctor not caught my low thyroid, I mean, that little dude that just zipped out the door may not even be here. But that's really kind of a cool thing. But once it's like dead or partly dead or just not functioning well, it doesn't get better. You just have to stay on medication the rest of your life, and they just alter the dosage based on your blood work. So I've been on it for like, how old is he? He's about to turn 14. So, 15 years. Okay, there you go. Long time. It's not hard stuff, and it's real easy. A lot of people are hypothyroid. So your endocrine system is controlled by your good old master. This is your master gland, your hypothalamus, right? And it's right in the middle of your brain. So it makes sense that it's your master gland. So that's your hypothalamus. So it's in your brain. It controls your hormone system, all of it. It releases hormones to another part of your brain called the pituitary gland, which is this little thing right here, that little guy. It's so little, but it sends hormones out to different organs, and it causes those organs to release hormones, or those glands to release hormones. So this is all of your daily physiological cycles. So things like the fact that we typically wake up when it's light, we typically sleep when it's dark, we get hungry at certain times of day. Some of us use the bathroom at certain times of day. It's like that regular, that's scheduled. So when you have this sort of daily routine for how you function, that's all because, thank goodness, your hypothalamus is there. It also controls your appetite. There is a condition called Prader-Willi syndrome. You ever heard of that? Prader-Willi syndrome is an issue with part of this whole system here, where you never feel satiated. You know what satiated means? You know what it means?
Like never content with how much you eat.
Ooh, good one, Claire. You knew it. That's a big word. Yeah. So yes, it means like satisfied as far as food goes. You're never satisfied. So when this system goes awry, you are hungry always. And that's an awful thing, because you tend to want to meet that urge and meet that need. Your body's telling you you're hungry, so you want to eat. So you gain a lot of weight, it gets unhealthy. I had a student years ago who didn't have Prader-Willi in particular, because it wasn't like this system was, the system had an issue. She'd actually had a brain tumor as an infant. And when they went in, this part of it was sort of, it was part of removing the tumor. So she lost part of that system. So she was always hungry. And just because she didn't have that functionality anymore. And she would hoard food. We'd find stuff, crammed in her backpack, and then she'd hide and eat it because she felt guilty about eating it, because everybody told her, stop eating that, stop eating that. And they had put her on ADHD medication, even though she wasn't really ADHD, but that medication reduces your appetite. So they did it to try and keep her from just constantly overeating, but she couldn't stop herself. I mean, she was just very overwhelmed with the feeling of being starving. It manages your sexual behavior, whether or not you have, they call it libido, which is like your urge to have sex versus not have sex. So some people that are like all the time looking for a good time, they have a high libido, versus the low libido, which is people who are like, nope, sorry, not interested. There's always jokes about like husbands and wives, like men do typically tend to have a higher libido. And we'll get to this when we get to reproductive system, but like men in particular, they don't have a cycle, right? Women have a cycle, and during that cycle, women's urge or feeling or need to want to have sex for reproduction is all biological. When those hormones peak, and that occurs right in sync with ovulation, it makes sense. Men don't have that. They're just kind of always there, right? So there's always jokes about that. You hear people teasing other people about it. It regulates your emotional responses. What do you cry about? What do you not cry about? What do you get excited about? What do you get scared of? Yep. Your body temperature. This is a big one, right? Are you always cold? Are you always hot?
I'm always cold.
I'm always hot. And it's gotten worse as I've, developed autoimmune disease. No, I'm always hot. It's awful.
I'm always freezing.
That's Jason. And you know what? Jason used to be a little heavier, and he used to have like a little higher blood sugar, and so he was a little less healthy, and he was always cold, always. He got healthier, like especially during the pandemic. He was one of those people that like really exercised. He started riding like every day on his bike, and he was doing, push-ups and planking and all that business. And he lost a lot of weight, put on muscle, blood sugar went down, and guess what? He wasn't cold all the time. So that was interesting too. So here are just this diagram. So pineal, hypothalamus, thyroid, thymus is down in here, like near your heart and your lungs. Pancreas, you guys saw pancreas when we did our dissections, right? It was really easy to see. And this is also tends to be included with your digestive system, right? Because it secretes insulin, which has to do with sugar, which you're taking in through your digestive system. And obviously things like testicles or testes, in this case, ovaries, placenta during pregnancy. The placenta is the only organ that a human being, a female human being in this case, men, you don't get the chance, sorry, but that a female human being can produce after being put together entirely. So when a person is developed, they don't tend to grow any new organs except placentas. Huh? Okay, well, he's outside. So a placenta is an organ you actually grow, and it takes a lot of energy, and it takes a lot of energy from your body, which is why pregnant women in their first couple weeks or first month or so, or first trimester, as they call it, like the first 3 months, are tired all the time. You tend to be very tired. This is hard work. Building an organ is hard work, right? You took 9 months to develop all your organs. Now you're developing one in 3 months. That's hard work.
That's my old swim instructor. She's like in charge of a
Mhm.
really big swim organization that's pregnant,
Mhm.
and she's like having a lot of problems.
Yeah, it's rough sometimes. But anyway, the placenta actually does secrete hormones to the rest of your body, which is kind of interesting because you grow an organ and then it ends up being an organ that acts like part of your exocrine system. It acts like multiple different parts of multiple different systems. So here's just some examples of your glands and what they do. So your pineal gland, that remember that little itty bitty one I showed you in your brain, the little itty bitty one?
Baby.
This is the one that makes your melatonin. So what's melatonin do?
Helps you fall asleep.
That's right. It makes you sleepy at the right time of day. Melatonin, good stuff. You can buy it over the counter if you need a little more. I tend to need a little more, so I have to take it. Actually, I don't need it to fall asleep, but one of the medications that I'm on for my autoimmune stuff, I don't have a problem falling asleep, but I wake up like every hour or half hour thinking it's morning, which is not
I do
great.
that too.
It's
Like, twice a
terrible.
night, I wake up and just like,
This is like incessant. So I take the melatonin because I stay asleep that way. Yeah,
Today I woke up at 6:50.
that's
I
nice.
tried to fall asleep, but I can't.
Yep, yep.
For a minute, I can fall asleep.
I like once my eyes open up, I just can't fall back to sleep.
Yep.
I
So
can't.
pituitary, which is also a little itty bitty one, right? So this is going to control FSH, LH. These have to do with ovulation. So these are ovaries. That's our target organ, menstrual cycle. ADH, your kidneys, osmoregulation. Okay, I want you to think about it. It's a big word. Think about what your kidneys do, what their function is. You guys should remember, and tell me what osmoregulation would mean. Do you know?
No, but I do know that the pituitary
Pituitary?
gland is just below the hypothalamus.
Hypothalamus, yeah. Osmoregulation. Anybody want to guess what would this mean? We see the word regulation in here. What's this osmo remind you of? Yeah? No? Lewis, you want to guess? Raise your hand. Okay, so osmo comes from the word osmosis. Remember, that has to do with how much water there is on one side of a membrane or another. Regulation would be regulating that. Remember, your kidneys control how much water is in your body. If they have too much water, it takes it from your blood, puts it into your bladder so you can release it as urine. If you don't have enough, it'll stop that from happening. So that's what osmoregulation is. And then you got growth hormone and all these other things. Milk production is prolactin, all this pituitary. Your thyroid here is your liver, your metabolic rate. Your adrenal glands, adrenaline and cortisol. Cortisol is your stress hormone. If you have your blood drawn and your cortisol high, it probably means you have some stress issues in your life. Pancreas, you guys know, we talked about it. Insulin. Your ovaries, if you have ovaries, which some people in this room do, some people do not, they're going to produce estrogen and progesterone, and their target organ is going to be the uterus, and that's all menstrual cycle related, along with the pituitary. And then testes are going to make male characteristics as well. So here's a little overview, different glands, what they do. So like your salivary glands, they come over here, and this is the whole process of how they function, like a really specific diagram, which you don't need to know. Here's an example though of a positive feedback loop here, mammary glands. So mammary glands, this is a great positive feedback loop example in the human body. So when a baby nurses, breastfeeds, the more the baby suckles, the more milk the mammary glands will produce, because it's almost like your body goes, this baby's still hungry, even though this breast is empty. So it will produce more every time. And that's how you can go from producing just enough milk to feed a tiny little 7-pound baby to enough to feed a 20-pound 1-year-old and get through most of it, with some supplement probably by that age. But that's how you can continue to produce the right amount of milk, because the more they suckle, the more it produces. And then sebaceous glands, these are the ones that get you oily. These are the ones you have to, clean the face down so you don't get acne.
Oh yeah.
And here's an example of ducts that open up right here to the surface, right? So this is, let's see, alveolar duct, tubular ducts, just showing the different shapes of the ducts. Ducts can be this one's fun. Look at that. So ducts can be all kinds of different shapes. So now here comes the reproductive system. Now, let me tell you, this is my favorite system to teach and to study. 2 reasons why. I find it absolutely fascinating. It's different in our 2 sexes, and it's just particularly interesting how intricate and complex it is on each system on their own, and then interrelated. Fascinating. So fascinating, in fact, that I did my my senior research project on a research related topic, reproduction related topic. And I love watching you guys squirm. So I will tell you this. So since I did my senior research project in college, which is a big thing that you do if you're graduating with a science degree, mine was on a reproductive related topic. It was about increasing sexual motivation in male mice, because this is, you've seen the Viagra commercials, you've seen them, the Cialis commercials, they're all over TV. This is before that, and female mice, sorry, this is before that was a thing. Those didn't exist. And those are all about like increasing sexual motivation in male humans. So I was looking for increasing sexual motivation in female mice. So I actually went and got what was kind of like the precursor to Viagra, which was a drug called yohimbine. It was great because I went to the health sciences department at my women's college and asked the doctor there, I said, here's my research project. Here's Professor Gray is signing off on it. And she gave me a prescription for erectile medicine. And I went to the local pharmacy and filled it, which was great because not every day you see some 22-year-old girl coming in and being like, I need to do drugs. So I actually gave that to female mice in various levels to see whether or not it increased their motivation. Basically, the male mice are always motivated, right? I wanted to see if I could get the female mice more motivated. And you could tell by certain characteristics. They almost always reject the male mice initially, and they can do it in a couple ways. They can run away from them. Sometimes they stand up on their hind feet and they literally box, they hit the male mice. And then if they are actually interested and they're motivated, they're like, okay, dude, all right, let's go, let's do this thing. They will assume this position called lordosis, where their back curves down and then their rear end curves up so the male mouse can come and mate. And I sat in a room in the dark with a little red light for hours and watched mice have sex. So that's what I did for an entire semester. So also I was on our student health advisory board in college, which meant I gave all the talks, and I gave all the talks on everything from anorexia and bulimia, which were huge in the 90s, or eating disorders, and they tend to be way more popular in female populations, way more prevalent in female populations. But I also did all the sex ed talks. And at one point we took a trip to Virginia Tech, which is where Jason went, but he wasn't there at the time. Went to an all male dorm, and I had a room for probably 60 guys. And I taught them about sex ed and STD prevention and birth control. And I have no problem with any of these words or any of these topics. And I love to watch you squirm. So if you're gonna giggle, giggle. If you're gonna squirm, squirm, but be prepared. I don't shy from it because this is my favorite stuff. So reproductive system. So first, let's watch this cool little fertilization video. It's just fertilization. You don't get to see how they got there. So that's probably better for you.
It's like
Oh.
10.
Why is that? Go away. Okay, it wants to be at the end of the video, not the beginning. Go back to the beginning of the video. There you go. Yeah, you think you should honor it? No, it's good. If it'll play. There we go. All right. There you go.
Fertilization.
Ah, this is great.
Of a single sperm facing
That's
incredible
semen.
odds. The American
My brother just wants to watch it.
It is the story of all of us.
See, I tell you, no problem with it.
During sexual intercourse, about 300 million sperm
Look at
to
it
the
go.
vagina.
Oh, cool.
Soon afterward, millions of them will either flow out of the vagina or die in its acidic environment. However, many survive because of the protective elements provided in the fluid surrounding them. Next, the sperm must pass through the cervix, an opening into the uterus. Usually, it remains tight or closed, but here the cervix is open for a few days while the woman ovulates.
Wait.
The sperm swim through the cervical mucus, which is thinned to a more watery consistency for easier passage. Once inside the cervix, the sperm continues swimming toward the uterus, though millions will die trying to make it through the mucus. Some sperm remain behind, caught in the folds of the cervix, but they may later continue the journey as a backup to the first group. Inside the uterus, muscular uterine contractions assist the sperm on their journey toward the egg. However, resident cells from the woman's immune system, mistaking the sperm for foreign invaders, destroy thousands more.
Its heads are getting chopped off.
Yep. No, just dissolved.
Next, half the sperm head to the empty fallopian tube, while the other half swim toward the tube containing the unfertilized egg. Now, only a few thousand remain.
Only
Inside the fallopian
Oh.
tube, tiny cilia push the egg toward the uterus. To continue, the sperm must surge against this motion to reach the egg. Some sperm get trapped in the cilia and die.
We're dead.
During this part of the journey, chemicals in the reproductive tract cause the membranes covering the heads of the sperm to change. As a result, the sperm become hyperactive, swimming harder and faster toward their destination. At long last, the sperm reach the egg. Only a few dozen of the original 300 million sperm remain. The egg is covered with a layer of cells called the parenchymal radiata. The sperm must push through this layer to reach the outer layer of the egg, the zona pellucida. When sperm reach the zona pellucida, they attach to specialized sperm receptors on the surface, which triggers their acrosomes to release digestive enzymes, enabling the sperm to burrow into the layer. Inside the zona pellucida is a narrow, fluid-filled space just outside the egg cell membrane. The first sperm to make contact will fertilize the egg. After a perilous journey and against incredible odds, a single sperm attaches to the egg cell membrane. Within a few minutes, their outer membranes fuse and the egg pulls the sperm inside. This event causes changes in the egg membrane that prevent other sperm from attaching to it. Next, the egg releases chemicals that push other sperm away from the egg and create an impenetrable fertilization membrane. As the reaction spreads outward, the zona pellucida hardens, trapping any sperm unlucky enough to be caught inside. Outside the egg, sperm are no longer able to attach to zona pellucida. Meanwhile, inside the egg, the tightly packed male genetic material spreads out. A new membrane forms around the genetic material, creating the male pronucleus. Inside, the genetic material reforms into 23 chromosomes. The female genetic material, awakened by the fusion of the sperm with the egg, finishes dividing, resulting in the female pronucleus, which also contains 23 chromosomes. As the male and female pronuclei form, spiderweb-like threads, called microtubules, pull them toward each other. The two sets of chromosomes join together, completing the process of fertilization. At this moment, a unique genetic code arises, instantly determining gender, hair color, eye color, and hundreds of other characteristics. This new single cell, the zygote, is the beginning of a new human being. And now the cilia in the fallopian tube gently sweep the zygote toward the uterus, where he or she will implant in the rich uterine lining, growing and maturing for the next 9 months until ready for birth.
Cool. Okay, question.
Holy cow.
Holy cow. Question.
So, do sometimes two make it into it at the same time?
No, two never do. Yep, only one. Yes.
How do you have twins?
Okay, two ways to have twins. One way is two eggs are ovulated, which can happen. Usually it's both ovaries, not one ovary twice, but two eggs can be ovulated at one time, and that way you get two eggs fertilized. That's fraternal twins, twins that do not look identical. Identical twins, very early on in the process, hey Drew, very early on in the process of dividing from that single cell, divide into two unique organisms. That's how you get identical twins. They start as one cell and they end up dividing into two. Yep.
Or also triplets?
Septuplets and stuff, that's nearly always lots of ovulation. So that does happen, especially if you're seeking like fertility treatment. They will give medicine to women that increase ovulation. So sometimes they ovulate lots and lots of eggs, and then you end up having, triplets or quadruplets. There was a mom back in the 90s when it first became like kind of standard treatment. who they called Octomom. She had 8 babies. It was kind of crazy. 8 babies, 8 children is like Claire's got 8 children in her house. That's not the end of the world. 8 children at one time is, that's kind of what, that's what dogs deliver, not what human beings deliver. So male reproductive system, we're going to go through them sort of quickly. I don't want to keep you here for too long, but we are going to go through them. Drew, you missed my whole talk about how I'll say all these words and I love to watch y'all get embarrassed. So your male reproductive system, what are these called? These are you have 2 of them. They're going to produce sperm and sex hormones, testosterone. These are equivalent to ovaries. They're contained within the scrotum that's external, and which maintains the temperature for sperm production. What is it, Drew? Not testicle, but close enough. Testes. Yeah, Drew, you get some money for that. There you go. All right, so there's 2 of them. Here they are. So this exterior part is the scrotum. There's your testes right here. You got 2 of them. This one, it's only kind of cut in half like that for the purposes of diagramming. I hope to goodness it doesn't look like this. Let's go to this next one. So what is this dual purpose duct for both semen and urine? Drew, once again. Well, penis is the organ, but there's urethra. Okay, that's right. Drew's got it. So interestingly, urethra. So women have 2 separate tracts for urination, reproduction. Men share. So the urethra, which is the tube that extends through the penis and is the opening at the end of the penis, that does both semen and urine. So it's dual purpose. What it does though is actually system cuts off one or the other. You cannot pee and produce semen at the same time. It doesn't work that way. It's either one system or the other. So the last one, this is the one you were going for, Drew. Who wants this one? So this is the external organ for sexual stimulation and intercourse. This is where semen comes from. This is the easy one. Go say it, Lily. Penis. Lily said penis. Yeah. All right. Save money for these. All right. So that's penis. Right. Okay.
Just saying that.
So sperm is produced in the testes. Here's how this works. It's produced here in the testes and it travels through a series of tubes and glands and it mixes with all kinds of fluid, which is how you end up getting semen and not just sperm. So it starts here, it goes through this epididymis, it travels through this big guy right here, which we're going to go over in a second. These are other glands that produce more fluid. That's the prostate. You ever heard of prostate? You may have heard of prostate cancer. It's not that uncommon. I think there's a whole thing in November now, right? Prostate cancer, everybody wears blue. They call it Movember. They grow beards. Yeah, that's it. And this is like the last bit of fluid. So, oh, and one thing, just whoops. So these, I didn't tell you these, but these right here, these big long tubes, these are called vas deferens. And if you've ever heard of the term vasectomy, that's a male sterilization procedure where they actually go in and it's intentional. It's for men who don't want to produce any more children. They go in and they actually separate it. They cut a chunk out here and they seal both ends on both of these. So while they continue to produce sperm for their whole life, it just sort of deteriorates and dies. It doesn't like swell up and explode. And that way it never, you never get any sperm all the way through. So that's a good thing. Now, let's see this female reproductive system real quick. This one is awesome. So fun, so complex. So we got lots of words here. So these are two of these. It's your oocyte production. Oocyte is your eggs and maturation and also sex hormones. Where is that? Where does that come from?
Your uterus.
Not uterus. Ovaries. Sky's got it. Ovaries. I love that people are going for this. Where are you, Sky? Woo! All right, these are your ovaries right here. Bing, bing. All right. Now these little guys here at the end, they're fringy. They're little fringy, look like fingers. They're actually called fimbriae. And your ovaries are not directly connected to these next things. What are these next things? They're also called oviducts. This is this tube right here that's going to connect the ovary to the uterus. And actually, this is where fertilization occurs. We saw it in the video. What's this tube called? Nobody knows? Okay, this is the fallopian tube. So if you've ever seen the movie Look Who's Talking, it was a 90s movie. It kind of starts where you see the little sperm swimming along and it's like, you're supposed to see this baby being born. And I'm sitting next to a friend of mine from high school. He was a Filipino guy, and that matters in this story. So I'm sitting next to Tony Solano. We're watching this in the movie theater and all these sperm are swimming along. He goes, look, it's a vagina. And I said, no, it's not. It's a fallopian tube. And he said, a Filipino tube. And I'm like, no, Tony, a fallopian tube. So anyway, it was great. It was super. So interestingly, just so you know, these, yeah.
Funny.
Tony's a riot. Tony's an absolute riot. So he's still he's like an adult skateboarder still, if that tells you anything. So ovaries and fallopian tubes, they actually don't touch. Those little fimbriae are like this at the end of the fallopian tube. And when the egg comes out of the ovary, when it ovulates, they catch it and pull it in. So it's like they see it coming and they catch it. When the ovulation happens, it's actually like a little cyst. It grows on the outside of the ovary, and the egg matures in there, and it's a fluid filled like a cyst, a sac. It gets bigger and bigger and bigger, and when ovulation occurs, it will actually pop open and kind of pop the little egg out. And some women can actually feel the pop. It's like, oh. And sometimes you can know whether it's your left or your right, because it alternates. 1 month it's left, next month it's right ovary, left, right. So you can lose an ovary and obviously still get pregnant because they do alternate. So what is this one? Chamber for embryonic growth and development. And they have an endometrium in here, which is the lining necessary for the embryo to grow in. Uterus is that's your uterus. All right, so uterus, that's this dude here, this chamber, this stuff, endometrium. It's this thick, rich, very vascularized tissue, right? And it lines in here. During the menstrual cycle, it will thicken up right before ovulation because it gets really thick, and it's like thick and nutritious. And it's like, come on, egg, I'm going to catch you. You're not going to bounce off of me. I'm going to be nice and fluffy. And if no egg comes through that gets fertilized, it comes right out, because that's what a menstrual cycle is. That's what a period is. That's what the bleeding is. It's endometrium coming out. Yes. You got the next one?
Estrogen, or is it?
Estrogen? We're not quite there yet. So this is the part that secretes mucus to enhance sperm mobility, and it also helps reduce embryonic infection. Anybody know what that one is? You know, what is it, Darcy?
Uterus.
Not quite. So this is going to be your cervix. This is right here. Okay. It's kind of, sometimes they call it like the neck of the uterus. Now, if you saw in the video, when the little spermies were swimming towards the uterus, it looked almost like a donut. Did you see it? It looked like a donut. It had like a little tiny hole in the middle that they had to get through. Interestingly, if a woman has had a vaginal birth, not a C-section, but a vaginal delivery, the cervix changes shape. It is no longer a little round hole. It becomes flat like a line. Changes shape entirely. So, oh, so this is the internal and external organ for both intercourse and childbirth. Darcy, that's the vagina. All right, so that's this dude kind of here. It looks like somebody cut it off. God forbid, what a terrible thing. So yes, very muscular and super fascinating, because if you think about it, it's the organ for both intercourse and childbirth. So if it's for intercourse, you know it has to accommodate something the size of an adult male penis. But a baby, a human baby, is much bigger. So think about how stretchy that organ is. It goes from something like this to something like this. I once heard a comedian say it goes from the size of a watermelon to, a lemon to a watermelon, and that was hilarious. So yeah.
There's a spider behind you.
Oh, that's okay. I'll let him do. Yeah.
Okay, so it prepares.
It does prepare. The cervix more than anything.
It becomes more elastic.
Yep, it does. Very good. So we're gonna run a little bit late, but I'm gonna keep going. So menstrual cycles, ovarian and menstrual cycles. We're gonna zip through this quickly. We're gonna assume a 28-day cycle, which is the average. Big difference, but the average is 28 days. Now, here's the thing I want you to take away from this. There's a lot of hormonal up and down. This gets almost like mathematical. And there's this stuff called corpus luteum. It's made by the egg. It helps, made by the follicle that produces the egg. It goes on and on and on. All these hormones. Okay. These are the days, roughly, in which conception may occur, but it really can only occur within like a 36-hour period. But somewhere, that 36-hour time period is going to fall somewhere in here, because right here, you've got thickening of uterine lining, and it's thickening again. Ovulation is in here. And then this is where your uterine lining is going to, this is where it's going to shed. So these are period days. So that's why the start of a cycle always starts with the start of menstruation. So when a period starts, when menstruation begins, that's the start of the cycle, is what they say. So anywhere in here is where pregnancy can occur, conception can occur. you don't know unless you're really, really in tune to your body. And there's all kinds of stuff women can do to tell when they're going to ovulate or likely when they're going to ovulate. It could be any of those days, but it's likely to be within a 3-day period. And the reason for that is because ovulation is going to last 24 hours and an egg that's not fertilized is going to die within 12 to 24 hours. But these little sperm, look at this. If the egg is only going to last 24 hours, and I'm telling you, it's like a 3-day period in which you can get pregnant, which is going to live longer, sperm or eggs? Which lives longer, do you think? Sperm. Sperm's going to live longer because say sexual intercourse occurs here on day 12 and ovulation occurs on day 13. Guess what? You can still get pregnant. If ovulation occurs on day 13, intercourse occurs on day 14, you can still get pregnant. You don't have to be 13, right? So somewhere in there. So lastly, we're going to go through this real quickly. Fertilization, you get a sperm and an egg. We're going to whip through them. Those, wait, female babies are born with approximately 1 million eggs. By the time you reach puberty, you only got about 300,000 left. 300 to 400 get ovulated within a reproductive lifetime. Men, however, don't start producing their gametes until they're between 12 and 15 years old. And a fertile male human, on average, produces about a teaspoon of ejaculate, that's semen, containing about 100 million sperm. And as you saw in that video, only one is the lucky guy. Yeah.
Produce 1,200 per second.
1,200 per second? Wow, okay, that's a lot. All right, so I'm gonna whip through these. So your sperm and egg together become your zygote, that's your fertilized egg. It burrows into the uterus, becomes a blastocyst. You don't have to know all of this stuff. You should know this, a full-term pregnancy, they consider, so here's how they track how pregnant someone is. They don't track it from the day of conception because typically most people don't know that exact date. They track it from the first day of the menstrual cycle. So it's the first day that your last period occurred. And that's the beginning. That tends to be like adding roughly 2 weeks to the age of the baby. So most women don't know they're pregnant till they're about 6 weeks pregnant. The reason is because it's a 4-week period where, you got roughly a 4-week cycle, a 28-day cycle, right? And then like 2 weeks go by and still no menstruation. You're like, okay, that's probably pregnancy because menstruation stops during pregnancy. So, but really the conception only occurred 4 weeks ago because you add those 2 for the beginning of the cycle. So 40 weeks is typical. However, 42, 43, not unheard of. 37, my babies were 38.2 and 37.4. So neither got to 40. Some people go past 40. Actually, 50% of women who are having natural, not induced, no C-section, no planned C-section, 50% of women, if left alone, will deliver after 40 weeks.
Oh,
A lot of OBGYNs will be like, oh, you're 40 weeks, let's induce your labor. 50% will deliver healthy afterwards. So there isn't any reason for that medically, but it happens all the time. Real quick through birth. All right. So after 30 weeks of being pregnant, the baby's now fully formed inside the lady's body. And soon it will be time for birth. That's this book right here. That's this book right here. It is full of ridiculous stuff. Yep. It's really hilarious. So you can look through this if you want. It's full of great stuff. So birth occurs in 3 stages. 1 stage, regular strong contractions occur, cervix dilates, cervix starts to open, and your baby turns, right? Stage 1 of birth is dilation of the cervix. Uterine contractions actually pull the cervix up, which causes it to thin and open or efface. And then with continued contractions, you want it to go about 10 centimeters. Now, I'm confused by why this is a blue model. And it looks to me like, this little, where'd it go? This lady here, I think this may be her baby because this is really blue and really weird. So stage 2 is the emergence of the baby. Look at the position of the baby. This is your standard, most common, most frequent, easiest delivery. Face down, which is called anterior, head first, which is called vertex. Anterior vertex is your easy baby delivery position. Comes out of the vaginal canal, and oxytocin, which gets produced during labor, and it gets produced in greater quantities if contractions are allowed to proceed naturally without medical intervention. No C-sections, no induction. Hold on. And that helps produce milk. So stage 3 is the placenta. The placenta will detach on its own and it will come right out. Usually it gets kind of pulled out because it's kind of big, and you will continue to contract until your placenta is out. When it comes out, it's like this big. They plop it in a bin. It's like this big plop, and it's got the umbilical cord attached to it. And I actually was like, can I please feel that? Because that's really cool. I built it. And it's like, it feels like, you ever felt the outside membrane of sausage? Like that. All right, so it detaches, it comes out really quick. We're already really late, so really quick. So these are all the different positions in which a baby can be born. Now, it would be interesting and does anybody know the position they were born in? Do you know?
I was butt first.
Oh, were you? So I was too. So I was actually born in a position called Frank breech, which really isn't shown here. It's similar to this, but with your arms straight up. So these are all breech positions, which are butt first positions. Actually, no, there's Frank breech. I take it back. I was born like that. Just like that. Isn't that classy?
I was born that one, that other one after that.
Yep. So like I know Drew was pretty much straight up normal, came out nice and easy. But Cole was what they call LOP. That's left occiput posterior, which means face up, not face down. And this is a C-section birth right here. They will take a nice low cut. They'll go in, grab that little baby's head, yank them out, and then they'll go back and get the placenta out. It's pretty cool. I'm going to send this one for you guys to watch at home because we are way behind. But this shows in 4 minutes. Listen. It shows in 4 minutes. It shows you from fertilization to birth. It does not show any of those like, bleh. There was a video for years that was really popular. They showed it in high school sex ed classes. And it was like all this stuff. There's this fertilization, there's this baby, and then it's born. And then it cut to a live birth scene of this woman, like right zoomed in on her like spreading vagina and this baby head coming out. And every high school student was like, because it was a thing for years.
Can you let me watch this?
Lastly, I'm going to leave this up for you. Oh, let me show you this one because this is quick. It's going to make me move it to YouTube. This is cool. It's what you call an on-call delivery. So it was a C-section. On-call means the baby is still inside the amniotic sac, which is not common. They're able to pull that baby out really gently inside the amniotic sac, which is a sac the baby lives in inside the uterus filled with water. And you don't see this very often, but on-call births are super rare, and that's really cool. Because you can actually they can put the baby down here and watch the baby move around, see the baby inside the sac. That's freaking cool. Yeah, they will. They'll let him out. Look, they're poking at him. Hey, little guy. Pretty cool, right? So lastly, I'm going to put up your topics. You can take a picture, write it down, whatever these are your test topics. And I'm going to gather up the other group, okay? Because we are super late, but we had a lot to cover. Yeah, it'll be there.
Okay.
All right.
Okay. We're okay. We're not gonna end the day. I just used all my hubba bubba. Digging down.
All right, gang, we're ready. Sorry, we are late.
Where is, I haven't seen my brother all morning. Where is he?
They're on their way back. All right, so I sent Coleman on a little errand.
Okay.
They are, oh, he called me. I don't know where he is. Anyway, they were trying to find bigger bobbers. Isn't that fun? Bigger bobbers, because we only had itty bitty ones for this lab, and I'm not sure they're gonna work. What I got in the mail was not what I expected. So let me see. I'm finding my iPhone with him to see what we can see where it is. So, all right, so what we've got is this is here. So let me text him real quick. I sent him on an errand and I'm like, can you find bigger bobbers? So bigger bobbers.
Maybe he said bigger. Maybe he thought it said bigger poppers.
Bigger poppers? I don't know. You know, I sent them to Walmart, but I don't know where they are.
One time my gymnastics coach sent her daughter to Walmart, and it's funny because she's like smaller than me. And she was trying to get these cookies from the top shelf, and she was just like jumping and trying to climb. And she was like,
all right, so hopefully they'll be back soon. But bobbers instead of the finger bobbers. I love that. So today's lab is 2 parts. All right. The first part of this lab is you're going to follow right along there. And the second part here that says touch and grow on the front. So this little touch and grow bit, it says label an agri plate with your team's name. I actually made enough agri plates you're gonna label with your own name. Everybody's gonna get a chance to do their own. So what we're gonna do instead of fingertips, actually, unless you want to do your fingertip as your specimen, I have got some sterilized swabs in the oven right now, and I will pull them out. And you're gonna take your swab and you're gonna find a surface in this house. You're gonna pick any surface you want, but you can't pick one somebody else has picked. So I'm gonna put my computer up with an Excel sheet and you're gonna put in your name, not yet, you're gonna put in your name and whatever surface. Rules are always the same. If a door is closed to you, you can't go in it, but that doesn't mean you can't use the doorknob, right? So you can use the bathroom, you can use any of these doorknobs, you can use the computer mouse, you can use your own cell phone. You can use the microwave, you can use the fridge door, whatever you want. You're gonna take your swab, listen, you're gonna take your swab and you're gonna really rub whatever that surface is, like for at least 30 seconds, maybe even longer, get a good sample. Then you're gonna bring it back and you're gonna put it on your agri plate, and I'll show you how to do it. But basically, you're gonna take your little swab and you're gonna go zigzag, zigzag, zigzag. You're gonna turn it, go zigzag, zigzag, zigzag. Then you're gonna take your agar plate and you're gonna make sure that your name is on the little piece of masking tape. So here they are here. I made mini ones so everybody can have one. So make sure your name is on this. There they are. Woo! Find bigger bobbers.
We got bigger bobbers.
Bigger bobbers.
Bigger bobbers, the Paw Patrol bobbers.
Oh, Paw Patrol bobbers. Thank you. Outstanding. We have bigger bobbers. So you're gonna write your name on here. Take it back together. Flip it over, top down, always, right? And then you're gonna stack them up for me. I'm gonna put them in the incubator. Now, hang on a second. I'm gonna be gone from this afternoon until Saturday night. So I'm gonna give Cole and Drew some instructions to kind of rotate them because it may be hotter towards the top and cooler in the bottom of the incubator because it's not a perfect incubator. Nice bubble. And anyway, we will look at it next week and see if we've grown anything. So hopefully we will. Finger bobbers. So you're gonna follow these directions. When you need water, use one of your 2 big pouring master paint bucket deals. These are adorable little Paw Patrols. Thank you. Yeah, do the work. Let's try not to make too much noise with them because that's obnoxious. So anyway, if you don't think you are capable of pouring without making a disastrous mess, then you can go outside. But if you use 1 bucket for pouring and 1 bucket for collecting, you should be absolutely fine. You have 2 different choices of ask for eye screws. You've got little ones and bigger ones. You can make your choice, okay? I don't know which ones are gonna work better. What?
And I wipe the swab on porta potty.
We don't have a porta potty.
Big for that.
Yeah, but we don't have it. So anyway, here's your finger bobber. Yeah, sure you can wipe it on honestly. You give his feet or whatever. Okay. Yeah, as long as you're nice to him about it. So
I
anyway,
call the bathroom door.
here's what you're gonna do, everybody listening. So you're gonna go ahead and run this first part of this lab. And when you're done, I'm gonna have the Excel sheet up over there. You're gonna go put your name in and put in the name of the surface you did. Then come to me, I'm gonna come to me to get a swab. Come to me to get a swab and a plate. Take your swab and your plate. Actually, you're gonna come to me to get a swab. Go wipe your surface, come back and get a plate and I'll show you how to do it, okay? Everybody good? Great, so go ahead and roll with it. You guys are gonna be great with this. This one is a fun last lab of the year. Thanks for the finger bobbers.
Last lab.
These are hilarious. I love it. Yep.
Stuff inside.
Yeah, these are jingly ones. I've never had jingly ones.
Your option was massive glow in the dark ones or weird ones that were like
We just go end up at Academy or something.
No.
Put it down on it. Okay, thank you.
the normal size ones were top of.
And if you need help cutting into your, here, reach punch real quick. If you need any help getting your first cut started in your bottle, I'll gladly like give you a deck with the thingy bobber here. Take your labels off the bottom. right.
We have to watch.
So we are going to be, are we listening? We are creating a model of a negative feedback loop. This pretty much models the way your pancreas works with blood sugar, insulin. So remember, one bucket is for pouring slowly, the other bucket is for capturing. You can also put your bucket in the bin there, the little gray bin while you're pouring if you're. And at one point it does say to pour about 100 milliliters, so I did get you a beaker you can use for that today, okay? Cool deal. I'm gonna go put the other thing up. Or I'll bring my computer over to me and I'll put it in.
Miss Danny,
Yeah,
this is Cole and I's last high school lab of our lives.
I'm aware. You're killing me.
The last
Wait, next year?
No.
There's no science.
Yeah.
Actually, that's more years in high school.
My last first middle school science lab. It's my last.
Your last,
Did you go next? Your first year lab.
he could, but he's not gonna.
It's too late. It's too late. You probably did it.
There is one or two schools that'll accept through like May, but do not bounce the balls. Just use the balls. Don't bounce the balls. Gosh darn it.
Dude, stop. Lewis, stop.
This is why you don't.
Follow directions first.
We're gonna redo, no, we're gonna read the directions. Please don't stab our bottom.
I'm gonna end this. It's still going. Like, I'm sorry.
I was trying to set it to